Welcome in Tilco Advisors. We empower construction material manufacturers with cutting-edge digital solutions. And now, welcome to our podcast, where we share insights from the world of smart construction technologies.
Imagine stepping onto a massive multi-billion-dollar construction site today. You've got autonomous drones buzzing overhead, mapping the topography. You see site supervisors walking around with augmented reality glasses, right?
Oh, yeah. And back in the trailer, they are spinning these glorious 3D digital models of the building that look like something straight out of a sci-fi movie.
Exactly. So looking at all of this, you would naturally think this industry is running on the absolute cutting edge of artificial intelligence. But get this. There is a staggering statistic from the 2025 RICS Artificial Intelligence in Construction Report.
It's a reality check for sure.
It really is. Despite all the massive hype, fewer than 1% of construction organizations have AI embedded organization-wide. I mean, nearly half of them have absolutely nothing in place.
Yeah, it creates this fascinating paradox. Because we're looking at an industry that literally builds the physical world around us, our hospitals, our data centers. Yet, when it comes to adopting the most transformative tech of our generation, they're hitting this invisible, impenetrable wall.
Okay, let's unpack this. That invisible wall is our mission for today's deep dive. We're going to explore exactly why AI is stalling out in the architecture, engineering, and construction space, which we'll just call the AEC industry moving forward.
Makes sense. It's a mouthful otherwise.
Right. So we want to figure out why structuring data is the ultimate non-negotiable prerequisite for unlocking AI's power. And to do this, we are pulling from a massive stack of research today.
We've got a lot to cover.
We really do. We've got recent 2026 academic papers from the International Journal of Web of Multidisciplinary Studies, Pinnacle International Journals, and the CIB W78 conference. Plus, we're blending in on-the-ground industry reports from tech firms like BuildOts and Eternal Technologies, alongside system reviews from HSO and Access CoinsEvo.
It gives us a really comprehensive look at what's actually happening out there.
Exactly. So why is there such a massive gap between the AI tools being aggressively sold to you guys in the industry and the reality of how these tools actually perform on a muddy Tuesday morning at a job site?
Well, the root of the issue is this fundamental mismatch between the technology itself and, the raw material it's being fed.
The data.
Right. Silicon Valley and the tech giants are incredibly good at building the engine. They're spending trillions developing these sophisticated AI models and fabricating the physical chips. But an engine, no matter how powerful, it can't run on nothing.
The BuildOts report actually sparked a great way to think about this. It's like Silicon Valley is handing the construction industry a state-of-the-art Ferrari engine.
I love that analogy.
But you can't just run a Ferrari without gas, you know? And right now, the data that construction companies have is essentially unrefined crude oil.
Yeah, you dump crude oil into a high-performance engine, and it completely stalls out.
Right. And in AI terms, stalling out means it starts hallucinating.
Exactly. And that analogy hits the core of the problem perfectly. Because general AI models, they're fantastic at generic tasks. Like, you can ask an LLM to write a polite email to a subcontractor.
Right.
Or summarize a safety meeting, and it works flawlessly.
Sure, it's great at the basic office stuff.
But if you want that same AI to predict the supply chain bottleneck for structural steel, or analyze why your profit margins eroded on your last 3 commercial projects, that requires high-octane, structured, vertical data.
And when it doesn't have that?
When it's forced to operate on that unrefined crude oil, the failure rate is alarming. Research from Eternal Technologies shows that in unstructured enterprise environments, AI hallucination sits at around a 20% error rate.
Wow. And I mean, in construction, a 20% error rate isn't just a typo in a marketing brochure. A 20% error rate in load-bearing calculations or cost estimation or safety compliance, that's catastrophic.
Oh, absolutely. Those errors compound through every single downstream decision.
So why does it hallucinate so much?
Well, the mechanism behind that 20% error rate is what's really important to grasp here. When an AI fails in an enterprise setting, it's almost never a failure of the model's intelligence. It is a data ingestion problem.
Meaning it's just confused by what we're feeding it?
Pretty much. If the context the AI is given is partial, outdated, or contradictory, it faces an impossible task. So it does exactly what it was programmed to do. It fills in the blanks using its generic knowledge.
And that gap filling is the hallucination.
Exactly. Trying to make sense of incomplete, messy data.
Wait, this is where I want to push back a little because I know how people are using these large language models right now, and they don't think they have a data ingestion problem.
Oh, I'm sure they don't.
Right, like a project manager will take their massive project manuals, right? 1,000-page PDF of architectural specs, their daily site logs, and they just chunk them up into like the 1,000-character pieces and feed them directly to a custom GPT. Why can't a construction firm just do that and let the AI sort it out?
So that approach is actually what the Eternal Technologies report specifically labels the naive chunking failure.
Naive chunking.
Yeah, it's the default reflex for most companies right now.
Right.
And it breaks down systematically. Let's look at the mechanics of why. Think about a complex construction document, like a building code spec. If you arbitrarily chop a 1,000-page PDF into 1,000-character text blocks, you violently strip away the semantic coherence of the document.
Right, you're just randomly cutting it up with scissors.
Exactly. So a sentence dictating the strict fire rating for a specific type of drywall might end up in chunk A. But the crucial exception to that rule, say, for moisture-resistant areas like a basement, might get split into chunk B.
Oh, I see.
Because the AI receives these as disconnected floating fragments, it loses all the domain knowledge that links them together. Without that explicit relationship, the AI doesn't know the exception applies to the rule, so it just guesses.
That makes so much sense. So if naive chunking and unstructured PDFs cause the AI to guess and hallucinate, what does the actual landscape of construction data look like today? Like, if I walk into a major contractor's office right now, where is their data living?
It is everywhere, and unfortunately nowhere useful. The industry reality, mapped out in reports from HSO and Access Coins Evo, shows a landscape of heavy fragmentation. A typical mid-sized contractor has their project schedules in one piece of software, their financials in a legacy ERP system.
Right, an enterprise resource planning system.
Yep. Then their worker availability is in a separate HR portal, and their quality control checklists are just sitting in massive, localized Excel spreadsheets. These systems do not natively speak to one another.
The sources actually refer to this phenomenon as digital exhaust. I just think that's such a brilliant way to frame it.
It really is.
It's this idea that data is treated as just a byproduct, right? Like the smoke coming out the tailpipe of the actual physical work being done, rather than being treated as a core foundational asset of the business.
Exactly. Organizations are generating terabytes of incredibly valuable operational information every day. But because it's treated as an afterthought, it remains siloed and messy. It's totally inaccessible to an AI that needs a unified, holistic view of a project to make any sort of intelligent prediction.
Wait, I'm getting stuck here again because there's a massive counter-argument to this. If the data from spreadsheets and PDFs is messy, fine. But the AEC industry has been using BIM building information modeling for years.
Sure they have.
We literally talked about those gorgeous, perfect 3D digital models in the intro. You can put on VR goggles and walk through a hospital before they even pour the foundation. Why can't the AI just look at that meticulously designed 3D model and figure it out from there?
It's a very common assumption, but it points to a massive industry misconception. An ITCon review recently broke this down. Digital transformation in the construction sector often stops the moment they achieve a pretty 3D visualization.
Really? Just the visual?
Yeah. While a BIM model possesses deep geometric data, meaning the computer knows exactly where a wall is in three-dimensional space, it's essentially a static database. It doesn't dynamically interact with the real world.
So it's just a picture, basically.
It was designed specifically for a human architect or human structural engineer to look at and understand visually, not for a machine to reason with.
So to translate this for you guys listening, it's the difference between LOD and LOAN.
Yes, exactly.
Level of detail, or LOD, is drawing a door in the software so it visually looks like a solid wood door to my human eye. But LOAN, level of information need, is giving the AI explicit machine-readable data attached to that door.
That is the exact distinction. An AI does not care what the door looks like on a monitor. It cannot see the door the way you do. It only understands the data attributes bound to that object, its fire rating, its acoustic properties, its weight, its exact maintenance schedule.
And this leads us to a huge technical hurdle. The industry shares these 3D models using a universal standard called IFC, or Industry Foundation Classes, right?
Yep, that's the standard.
But a study from the Pinnacle International Journals reveals this fatal flaw for AI integration. IFC was built for human data exchange and software archiving. It was never designed for machine reasoning. It's full of generic classifications that lack the explicit semantics an AI needs.
Right. And to correct this, researchers in that Pinnacle study outlined 5 pillars of AI-ready data that a model must possess if you want to avoid those hallucinations.
Okay, lay them out for us.
First is structural consistency. The data has to follow a highly predictable schema without redundancies. Second is semantic completeness, meaning all those non-geometric properties, like the fire ratings we mentioned, are explicitly defined.
Right.
Third is geometric fidelity. Fourth is temporal coherence, linking the physical 3D geometry to time, like a delivery schedule. And fifth is contextual richness, integrating the model with outside data, like weather patterns or live IoT sensors.
And if any of those pillars are weak, the whole AI integration just collapses.
It does. What's fascinating here is how incredibly sensitive AI is to that third pillar, geometric fidelity. There's a specific issue highlighted in the research called the BREP problem, which stands for boundary representation.
I saw this in the notes, and the implications honestly blew my mind. Walk us through a real-world scenario of the BREP problem.
Okay, let's picture a human engineer looking at a 3D model of a hospital room. They are zooming in on the joint where a dry wall meets a concrete floor slab. To the human eye, it looks completely flush and perfect.
Makes sense.
But mathematically, under the hood of the software export, there might be a microscopic gap between the bottom of the wall and the top of the slab. We are talking a fraction of a millimeter.
Which a human would never even notice, and even if they did, their brain would autocorrect it. They know the wall touches the floor.
Right, but now put an AI in charge of an automated quantity takeoff. You want the AI to calculate the exact volume of acoustic sealant needed for every single floor joint in a 50-story hospital.
Oh boy.
The AI relies entirely on the mathematical intersection of boundaries to calculate that volume. Because of that microscopic gap, the boundaries are mathematically broken.
So it just fails.
Yeah. The AI doesn't have the human intuition to say, oh, they obviously meant for these two things to touch. It will either crash, fail to calculate the room entirely, or give you a wildly inaccurate material order.
That is wild. The AI has immense processing power, but zero common sense. That is exactly why the geometric fidelity has to be mathematically perfect, not just visually acceptable to a human.
Precisely.
So, if the native IFC files the industry uses every day are full of these semantic gaps and micro errors, how do we fix it? Because we can't just wait another decade for perfect software.
We don't have to wait. The solution computer scientists are developing involves creating an intermediate layer, something called a semantic layer, built on knowledge graphs.
Like what search engines use to connect concepts and serve up relevant answers.
Very similar mechanism, yes. Instead of relying on a rigid hierarchical file like an IFC export, a knowledge graph translates the building data into a massive web of nodes and edges. It forces explicit logical relationships. To do this, they use ontology models designed for the built environment, like BOT or IFCLWL.
Okay, let's ground that real quick. Think of an ontology model like a master dictionary combined with a roadmap. It doesn't just define what a water pump is. It defines exactly how a water pump is mathematically allowed to connect to a copper pipe in the digital world.
That's a great way to visualize it. So instead of just looking at a dumb list of building parts, the knowledge graph tells the AI, this specific temperature sensor is physically located inside this specific patient room, which is structurally part of this specific HVAC zone.
Here's where it gets really interesting. In a study presented at the CIB W78 conference, researchers applied this exact knowledge graph concept to a project called the Open Family Home.
Oh, this is a great example.
Yeah, they took a digital twin of a real house and tracked all its indoor environmental sensors. But as always happens in the messy real world, some of the physical sensors dropped offline. They started producing missing values and crazy data outliers.
And in a traditional database, those missing values would instantly ruin an AI's predictive energy model. The crude oil is contaminated.
Right. But because this home's data was structured in a knowledge graph using that semantic web, they didn't just have to manually delete the bad data or start over. The AI was able to use a mechanism called implicit reasoning.
Which is huge.
Because the ontology model explicitly mapped out the relationships of the house, the AI could look at the broken temperature sensor, scan the graph to see which other sensors were semantically similar, meaning they were located in the same physical room, measuring the air at the exact same time, and it could logically calculate and backfill the missing data with near-perfect accuracy.
It inferred reality because the data structure taught it the fundamental context of the physical environment. That is the true power of a semantic layer. But of course, the ultimate goal for the industry is to not have to guess or manually fix data at all. right?
Naturally.
The future relies on standardizing the input from the very beginning of the supply chain, long before it even hits the job site.
Which brings us to the DPP, the Digital Product Passport.
Yes, the digital product passport fundamentally changes how data enters the ecosystem. Under the current workflow, when a contractor buys a highly specialized HVAC unit, the data about that unit usually arrives as a PDF manual.
Oh man, don't remind me. Some poor intern or junior engineer has to spend 3 days manually typing specifications from that PDF into a spreadsheet or a BIM model.
Exactly. It is painfully slow and highly vulnerable to human error. The DPP mandates that manufacturers provide machine-readable, standardized data fields for their physical products straight from the factory.
So it's essentially a digital birth certificate for every single brick, water pump, and window frame.
Yes, it contains the material composition, exact mathematical dimensions, maintenance intervals, and its lifetime CO2 footprint. And because it's standardized, let's look at how the workflow changes. The moment that physical pump is scanned on the loading dock, it plugs directly into the project's openBIM workflows via an API.
No manual entry at all.
None. The AI reads the passport, understands perfectly what the object is and how it behaves, instantly updates the 3D model, and automatically recalculates the entire building's energy efficiency simulation.
Okay, this is all incredibly compelling on a theoretical level. Knowledge graphs, semantic reasoning, APIs replacing manual data entry. But let's bring this down to earth for you guys listening right now. If you work at a mid-sized commercial construction firm, or you're consulting for one, how do you actually apply this today? Before a company goes out and drops $2 million on shiny new AI software, how do they get AI ready?
Well, it starts with an organizational philosophy outlined in the Bill Docs and Connected World reports called active governance. You have to fundamentally change human behavior around data before you can change the technology.
That sounds like a heavy lift.
It is. Companies must stop accepting digital exhaust as a standard deliverable.
Active governance isn't just a tech buzzword then. It means on Tuesday morning, a project manager has to actually look a subcontractor in the eye and say, no, I will not accept your weekly update as a messy PDF attachment. You must input your labor hours and material deliveries directly into our central system format.
Spot on. It requires immense discipline. Active governance means establishing cross-functional steering committees. You need leaders from site operations, IT, safety, and finance sitting at the same table, defining strict, organization-wide rules for how data is collected and formatted.
But where does a company even begin to physically store and organize all this? We just established that local spreadsheets and siloed legacy apps are the enemy here.
This is where the financial and operational insights from Access Coins, Evo, and HSO really come into play. The smartest contractors aren't trying to build a custom, ground-up AI database from scratch.
They're not.
No. They're using their existing enterprise resource planning systems, their ERPs, or centralized dataverses, as the foundation. Your ERP is already the central nervous system for your payroll and your invoices. You have to leverage that existing infrastructure to centralize your project schedules, your supply chain data, and your workforce tracking first.
Okay, that makes sense.
If your ERP isn't acting as a single unified source of truth, your AI has absolutely no foundation to stand on.
It's the old adage, right? You have to clean your house before you buy the smart home system.
Exactly. And once that house is clean, the payoff is astronomical. When you have structured, unified data, AI ceases to be a gimmick. It stops hallucinating and becomes a 10x multiplier for your business operations.
Let's talk about that multiplier because the multidisciplinary study from the IJWO's paper lays out some mind-blowing real-world examples of what happens when you actually get this structure right.
Oh, the capabilities are incredible. When the fuel is refined, you unlock operational capabilities that human teams simply cannot perform at scale. Take predictive scheduling, for example. In a traditional setup, if a critical steel delivery is delayed by 2 weeks, a project manager has to guess how that delay will impact 50 other trades, based mostly on gut feeling and, like, a whiteboard in the trailer.
Which is stressful and highly inaccurate.
Totally. But with structured data, an AI can instantly process the temporal logic of the entire master schedule, cross-reference it with historical performance data from your ERP, and auto-generate the most mathematically optimized recovery schedule in seconds.
And it goes way beyond just fixing the schedule and protecting the budget. The safety applications are arguably the most important shift. The IJWOS study heavily highlights automated safety management using computer vision. But again, the camera is just an engine. It only works if the AI understands the context of what it's looking at.
Right, and they specifically mentioned the YOLO family of object detection models.
Yep.
Yeah, it stands for You Only Look Once. These computer vision models can process live video feeds in milliseconds, but a camera just sees pixels. If that camera feed is temporally and geometrically linked to a structured BIM model, meaning the AI knows the exact spatial boundaries of the site and what heavy equipment is scheduled to be operating that day, it can instantly flag hazards.
Let's picture this for a second. Imagine a busy Tuesday on a high-rise project. You have a massive excavator pivoting to drop a load of rebar. A traditional camera might just record an accident, right?
Sadly, yes.
But because the AI has a semantic understanding of the site's geometry and the scheduled work, it can detect dangerous worker-machinery interactions as they develop. It can literally see that a worker has stepped into the mathematical blind spot of that excavator, recognize the spatial violation in real time, and trigger an automated siren or alert before the machine even swings around.
It's incredible. It moves site safety from a reactive clipboard inspection process to a proactive continuous monitoring system. But we have to circle back to the core premise here. If the AI does not have that geometric fidelity, if it miscalculates the 3D space because of a tiny B-rep error, or if the camera data isn't temporally linked to the active schedule, it cannot make that life-saving call.
The engine is there, the camera is functioning, but the fuel is contaminated.
Exactly.
The golden rule here is inescapable, isn't it? Data infrastructure must precede AI adoption.
Every single time.
Okay, let's bring this all together. We've covered a massive amount of ground today. We started with the realization that AI is a phenomenally powerful engine, but right now, it is starving for the right kind of fuel. You cannot just throw unrefined crude oil, messy PDFs, siloed spreadsheets, or even visually stunning but static 3D BIM models at an algorithm and expect it to magically optimize your construction project.
It will inevitably stall out. It will hallucinate, filling in those semantic gaps with dangerous guesses.
And to stop the hallucinations, we have to bridge the semantic gap. We have to move from human-readable visual data to explicit machine-readable structured data. That means enforcing those 5 pillars of AI readiness, moving toward knowledge graphs that establish explicit logical relationships between building components, and eventually embracing digital product passports so that every physical object brings its own structured data right to the table through an API.
And on a practical level, for the teams listening, that means implementing active governance today. Centralize your daily operations into a unified ERP. Treat your operational data as a high-value asset that requires strict standards, not just digital exhaust, to be ignored at the end of the month.
So whether you're prepping for a massive construction tech meeting tomorrow, or you're just insanely curious about how the AI revolution is finally hitting the physical world, remember this: the companies that win the next decade won't be the ones who bought the most expensive AI software licenses. They will be the ones who built the cleanest, most rigidly structured data pipelines. So what does this all mean? We leave you with this final thought to mull over. For centuries, we have valued construction companies based entirely on their physical output, right? The suspension bridges, the skyscrapers, the hospitals they leave behind. But as this industry undergoes its ultimate digital transformation, the very definition of value is shifting.
It really makes you think.
It does. Think back to that opening statistic. Fewer than 1% of organizations have embedded AI. So in the future, will the most valuable asset of a 21st century construction firm actually be the physical buildings they erect out of concrete and steel? Or will it be the proprietary, perfectly structured, semantically rich data models they own, the exact refined fuel required to train the world's best building AI? Something to think about the next time you walk past a drone buzzing over a job site. Thanks for joining us on this deep dive.
That's it for today's episode. We hope you enjoyed exploring how digital workflows are transforming the construction industry. Don't forget to subscribe and join us next time for more insights into building smarter. Head over to our website. You'll find everything you need to keep building smarter. To give you the best listening experience,